In this video, we're going to learn how to use trig functions to find a side length of a right triangle. Trig functions allow us to find a side length when we're only given one other side length. We will also be given an angle. The angle that we consider is known as the reference angle. So if you look at the two diagrams below, you can see that the left side, my reference angle, is angle A. From this point of view, the side length BC is called the opposite side because it's opposite from my reference angle. Then, from my point of reference angle, angle A, the adjacent side that we're going to consider is AC. And then our hypotenuse is always going to be the side length that is opposite from the right angle. Now, if our reference angle changed and our reference angle is angle B, this acute angle, then angle AC is considered the opposite side. It's opposite from my reference angle, and my adjacent side is now BC. So you can see that BC and AC switched positions when our reference angle changed. Again, the hypotenuse will always be the side across from your right angle. We have some relationships with right triangles when we're using our trig ratios. So if my reference angle is angle A, we have a relationship between the opposite side and the adjacent side. We also have a second ratio relationship between the adjacent side compared to the hypotenuse. And the last ratio for our trig functions is the opposite side compared to the adjacent side. Now let's take a look at those trig functions. They are sine, cosine, and tangent. So when we have the sine, abbreviated SIN, of theta, this symbol is just a Greek symbol, and it just represents, like normally we would use x, so just some angle. The sine of that angle is equivalent or equal to the ratio of the opposite side over the hypotenuse. Then we have cosine. The cosine of theta is equal to the adjacent side over the hypotenuse. And lastly, our third trig function is tangent. The tangent of theta is equal to the opposite over the adjacent side. So you're going to want to make sure you have this diagram and these trig functions written in your notebook, and always have them available when you're working with these type of problems. So a little way to remember which side lengths go with which trig function, we can look at it as SOHCAHTOA. So tells us the sine of our angle is equal to the opposite over hypotenuse. Ca is cosine is equal to the adjacent of the hypotenuse. And then our last one, the TOA part, is tangent is equal to opposite over adjacent. So SOHCAHTOA can help you remember which ratios go with which trig function. Now, when I was first learning this, I just remembered that the opposite side, if it is used, it always has to be in my numerator. And when the hypotenuse is used, if it is used, it has to be in the denominator. So opposite always has to be on top, hypotenuse always has to be on the bottom. And then when you're dealing with adjacent, it can be either, depending on what it's matched with. So like we were saying, a benefit of the trig functions is if you're given one of the acute angles and one side length, you will be able to find other side lengths of the right triangle. So always draw a diagram. Always place the angle degrees inside the triangle. So here we have theta inside to represent an angle measurement. Then always know which is your reference angle and then label. So since A is my reference angle, BC is my opposite side, CA is my adjacent side, and BA is my hypotenuse. So we're going to use the calculator, and you can see here we have sine, cosine, and tangent. And the first thing is you always, when we're working with trig functions, make sure that you are in degree mode. Sometimes it defaults to radians. So the way you get there is you just click mode and then highlight the degree and then click enter. So we have sine, cosine, and tangent. These are the features of the calculator that you'll be using for this lesson. So let's look at our first example. Our reference angle is 42 degrees. Now let's label our part. So from this standpoint, X is your opposite side. The 25 is always your hypotenuse because it's across from the right angle. And then this side right here is your adjacent. So we're trying to find X, which is the opposite, and we're given hypotenuse. So the trig function that we're going to use is sine because sine deals with opposite over hypotenuse. So let's write a proportion. So the sine of 42 degrees is equal to the opposite side over the hypotenuse. Now we're just going to use cross multiplication. Remember, this is really over 1, so we're going to cross multiply. We get X equal to 25 times the sine of 42 degrees. So I always put my coefficient out front. So X is isolated, so now we just need to pick up the calculator. And in the calculator, you're going to click 25, and then click the sine feature, and then click 42. And then click enter, and our instructions say round to the nearest integer. So here was my work. Here's the calculator. You can see what we put. We get 16.7. So it says integer. So we're going to say X is equal to about 17. Let's take a look at our second example. So this time our reference angle is angle B. And let's label all of our parts. So CA, which we are not going to need, this is going to be the opposite side. My adjacent is 17, and my hypotenuse across from the right angle is X. So we need to look at the trig functions below and see which ones deal with adjacent and hypotenuse. That's going to be cosine. So we're going to use cosine of 35 degrees is equal to 17, my adjacent, over X, my hypotenuse. So we're looking for the hypotenuse length. We're going to cross multiply. We're going to get X times cosine of 35. This time we have to isolate X, so we're going to divide each side by the cosine of 35. And now in our calculator, I'm going to use the N over D button and put in 17, and then in the bottom just cosine 35. And so when we enter that in our calculator, we get 20.753 and so forth. It says round to the nearest integer. So X is going to be 21 in length. Okay, our third one, our reference angle is back to angle A. And let's label X is my opposite. Hypotenuse, we're not trying to find the hypotenuse. We've not been given it, so we won't be using the H. And then 13 is your adjacent length. So the trig function that deals with opposite and adjacent is tangent. So the tangent of 32 degrees is equal to the opposite side divided by the adjacent side. Here's my proportion. Let's cross multiply. Remember to bring your 13 out front as your coefficient. X is isolated again in this case, so just in your calculator, put in 13 times tangent 32. And we get 8.1233 and so forth. So rounding to the nearest integer, my side length of BC is 8. Now remember, if it asked you to go on to find the hypotenuse. There's two ways you could do it, or probably more than two, but one way is you could use the trig function. Now that you know the opposite side, okay, is 8, okay, you could use sine of 8 over your hypotenuse, or you could use the Pythagorean theorem. Okay, let's look at 3 more. So in this first one, our reference angle is 49 degrees. We have been given an opposite value, and we are trying to find the adjacent value. So opposite and adjacent is going to be tangent. So we're going to use the tangent of 49 degrees is equal to the opposite over the adjacent. We're going to cross multiply. We're going to have to isolate x. And now, in the calculator, I'm going to use the n over d feature. So calculate this. And I'm going to put 19 in the numerator, and then tangent 49 in the denominator, and I get 16.5. So we're rounding to the nearest tenth here, so 16.51. So I am going to say that length is 16.5. The next one, we have been given the adjacent and the hypotenuse. So we're looking for the adjacent. We've been given the hypotenuse. So adjacent and hypotenuse is cosine. So we're going to use the trig function. Cosine of 45 degrees is equal to adjacent x over hypotenuse 16. We have our proportion. We're going to cross multiply. We can see x is isolated. So we can just immediately pick your calculator up. 16 times the cosine of 45. Now I got 8 root 2. I want a decimal, so I toggle and I get 11.31. So let's say 11.3. And the last one, our reference angle is 71. We have opposite and we have hypotenuse. So opposite and hypotenuse is sine. So the sine of 71 degrees is equal to opposite over hypotenuse. Cross multiply. So x is not isolated. Let me back up there and erase this. So we need to isolate x. So we're going to divide each side by a sine of 71 degrees. So in your calculator, use the n over d feature. And my numerator is 18. My denominator is sine of 71. I get 19.03. So I'm just going to say 19. So x, the length of x is about 19.